So today we move to our new topic under Gem 301, and Gem 301 is advanced math, right? So we are starting with differential calculus. Remember, we introduced the concept of differential calculus in the last class, but as a recap, let's have our xy axis. This is our y and this is our x. And I said whenever there is a change, remember, differential calculus actually represent a real life concept. Changes are occurring on a daily basis, for example, price or income. Now, assume this represent quantity of goods you buy, and this represent the price, or this represent your income. If at the initial price you were able to buy, if at this price, let's say y1, you were able to buy so quantity, and there is now a change, there is a change in price, which is upward shift. Definitely, let's look at what will happen here. So I think I don't want to use the concept of price. Let's go with income. So we are relating income with what you can buy. So at lower income, you can purchase so a quantity of stuff. When there's increase in your income, there's that tendency that you purchase more. So what then is differential calculus, or what does differential calculus play here? There is a change, there is a change in the quantity you can buy, and let's call that change a change in x. And there is also a change in price, and that is called the change in y. And of course, these slopes define the steepness. Now when we talk about change, that change in x or that change in y, which led or influenced change in x, brought about a difference. And take it that we have 5 here and here we have 2. The change in y means 5 minus 2, and this means we should represent it y2 minus y1. And assume initially this was 4 and this is 9. Then remember, it is always the highest minus the 4, the lowest. So we're going to have a change of x2 minus x1. This is what brought about the concept of differential calculus. So anytime we talk about differential calculus, it simply means changes that occur on a daily basis. Your age, your consumption level, your income level, your purchasing power, your the changes that occur in terms of promotion and everything. So differential calculus explain the concept of changes that occur in our daily lives. So having said that, let's now look at some basic principles of differential calculus. Before we go into principles of differential calculus, there's something we have to take a look at, which is the first principle. The principle guides what we do. The principle says that for every time that I have y, if my y is such that it is x to the power of 2, and there is a change in x, it will also affect y, because y is depending on x. So assuming now I have x and there is a change in x, it will cause y to also have a change in y. But remember, that change in x is raised, remember x is raised to the power of 2, it means the change will also be influenced by this. Now when x plus change in x is raised to the power of 2, we can write this as change in x times x plus change in x but y will be equals that change in y. I said something. For every time that there is a change in x, it will influence y to change. I gave you a typical example: your income, your purchasing power, or employment. If there's your promotion, it will cause this to increase or decrease. But we are looking at the positive change. So expanding this bracket, this is going to be x. You use this one, you times everything, x plus the change in x. Then that change in x, this is the second term, x plus the change in x. Remember, we have y plus the change in y. Simplifying your right hand side, x times x will give you x squared, plus x times the change in x is going to be x change in x. Change in x times x will give us x change in x. Then change in x squared, change in x times change in x will give us change in x all squared. And we're going to have y plus change in y. So let's proceed by simplifying the right hand side. So our x squared here, so if you see this and this term, they are the same. So we have two of them the same as each other, right? Then plus the change in x all squared, y plus change in y. Now all that we have been doing, we are really not interested in everything that is happening here. We want to know, since x changed, what is its impact on y? And that impact on y is what we call the change in y. It therefore means that we are only interested in knowing about the change in y. So it means take y to that side. We are not interested in y. We are only interested, we already know what you are. If y was 3, it means y is still 3. We are only interested in knowing that change. Therefore, you take y to the other side, and this is going to be x squared minus 2x change in x plus change in x all squared minus y. So I'm driving at something. From the first principle, I will now help you to understand the basic rules of differential calculus. So taking this further, sorry, I have to erase this part. My change in y is now going to be x squared plus 2x change in x plus change in x all squared. Remember, the initial question was y is equal to x squared. So where your y is, remove it and replace it with x squared. So look through and see if there is something we can remove. So change in y is now going to be x squared plus, okay, there's no need going through that. If you see we have x squared, the positive one, and we have x squared, the negative. So it means this will cancel, this will cancel. And what have you noticed? The original value of x, we are not also interested in the original value of x. We are only interested in that influence of change in x on change in y. So you will discover that every term that is left is capturing the change that occurred in x. And this is going to be change in x all squared. So let's take it further again. So we are looking at the change in y that is being influenced by change in x. Take it that y is 5 and the change in this is 2. We know that this will be 2.5. This is the change we are talking about, but we don't know the value of the change in y or the value of the change in x. So this is now going to be dividing through by change in x. We are going to have 2x change in x. Remember, we're looking at the influence, so this will also divide by the change in x. And change in x squared means change in x times change in x divided by the change in x. So this will cancel this and this will cancel 1. So the change in y over the change in x is now going to be 2x plus change in x. So I'm sure you must have heard about the principle of limit. So we now take the limit, and anytime you're checking the limit, the change in y becomes the y over the x, and this occurs at the point where the change becomes so small as it approaches 0. It therefore means any place you see the change, replace it with 0. So this therefore implies that this function can be written as change in y over change in x is equal to 2x plus, remember change in x is approaching 0. We don't know the exact change, but as x keep changing, it will turn towards 0, and this will become 0. And if we simplify that further, we are going to have our change in y with respect to change in x to be 2x. So it means that if x change, let's say by 3, its influence on y will be 2 times the influence on x. That is 2 times this, and that will be 6. But we are not given the value of x, so that becomes the answer. So we solved that question using the first principle of differential calculus. But instead of going through the long process of differential calculus, differentiating by first principle, we have some basic rules that guide differential operation. And the first one is what? The power rule. So this is what I'll be teaching you throughout this week. When we are done with the power rule, we'll treat the sum and difference rule. We'll treat the product rule. We'll treat the quotient rule. And when we are done, we'll treat the chain rule. And when we are now done with all these rules, we'll look at its application in courses like economics, which relate price and quantity, income, employment, and all of that. Application of differential calculus. So this is the guideline, or this is the outline for this course of study. So if you want to be or have full access to the materials, there is a Telegram group for this. You can't have access to it as it is well structured, because here I'll be posting just one example, but the full course will be dropped on the Instagram page with simple explanation. So this is what you're going to learn throughout this week.